Very interesting thing about Punjab. I don't think many of you would be knowing. I think Gaganpreet and Arshdeep are from Punjab. Anybody else from Punjab? All right. So Punjab. In Punjab, people have gender neutral names. Gender neutral names. What does this mean? Normally, you take any name, Palak. I don't need to tell you the gender. You can know. If I will tell you Aman, I will tell you Anjali, I will tell you Keshav, I will tell you Shubham. You can predict the gender. The names are not gender neutral. Names, specific names are there for specific genders. But in Punjab, people have gender neutral names. So Harvinder is a name of a male or a female. Arshdeep, you are a male or a female? Well, I was a student whose name is Arshdeep and she is a female. Now, how can you probably guess? One way to guess is the title. So, Singh is the male and Kaur is the female. So, interesting sociological fact. Chalo. 35 of you are here. Hey, Palak, all the names are mostly gender neutral. All the names can be used in Punjab. Most of the names can be used by both the male and female. There is no, as I told, there is the names are gender neutral. You cannot predict, or there is no specific names which are fixed for the male or for the female. Janani is saying I have completed class 6 geography and charity book. Now presently I am college first year. Can I start to take notes or should I, after completing up to class 12? Take notes. कम से कम जो क्लास में बता रहा हूँ तो आई डोंट थिंक these things are mentioned in the book. If you will not take notes, you will forget everything that I have told. कुछ याद नहीं रहेगा. चलो ठीक है. Let's start then. Ready for another roller coaster ride? It will be very tricky. So we were discussing about temperature and heat. Now, when we talk about temperature, and some of you rightly said that temperature is the degree of hotness and coldness of the air. Pehले, I will give you an example and then you can understand what is hot and what is cold. That will be easier. So our exosphere, it is hot without feeling, like typical Bollywood ki निगेटिव रोल वाली जो हीरोइन हो गई, हॉट बट नो फीलिंग्स. सो कौन सा कैरेक्टर याद आता है? मुझे तो कुछ नहीं याद आ रहा. बट the heart without feeling. This is our exosphere. Why is it so? See, to feel the temperature, what your thermometer does, when you put the thermometer in your mouth or wherever you want to, when you put or you put it in a beaker to test the temperature, what happens? That the molecules of your mouth, or the molecules from the water, it came in the touch with the surface of the thermometer, and it heats it or coolly depending upon what is the surface of it. So basically what's happening, if you are hot, your body is hot, so the atoms in your body will be hot. How do you know it's hot? It will be moving at a very high speed. They will be like for hours. And if you see a cold body at the microscopic level, mute कर दिया जाए सबको. Yes, done. So if you'll see at a microscopic level on a cold body, their atoms will be at peace. ये आलसी पड़े हुए हैं, इनको कोई फर्क नहीं पड़ता. So this is a hot body, this is a cold body. On the outside, you cannot say the difference. लॉकडाउन के टाइम में मैं रोटी बनाना सीख रहा था. I was in Bangalore all alone. So I had learned how to make rotis before, but that was the first practical experience. And what happened one day, that I put like roti garam jab bana lete, so I was trying to roast it on the fire directly. And something happened. Instead of picking the roti or something, I just hold the hot iron tawa with my hand. पूरा तवा ही पकड़ के मैं हटाने चल गया था. And I learned. तो पूरा हाथ ही जल गया. So on the outset, we cannot say what is hot and what is cold. Both surfaces will almost look the same until unless it's very hot and it's almost glowing. The difference is at the atomic level. In a hot surface, the atoms are moving at a very high speed. They have high kinetic energy with them. Cold surfaces are lying as idle. So when you will put a thermometer in a hot surface, quickly these hot atoms will heat the thermometer, and in that, if you don't know, there is mercury in your normal thermometers. So the mercury will start rising because it will expand when heated. So it will start rising, and you will see that there is then it will tell you how much temperature it is. If you put a thermometer in the cold surface, instead of giving it heat, it will start withdrawing heat from it. It will get cooler. Now think about exosphere. You have a very good thermometer which can resist 1000 degrees Celsius temperature. But when you put that thermometer into the exosphere, there are no particles. There is nothing which can conduct the heat to the surface, because in exosphere it is very less dense. There is no air particles, very less air particles. So you will not feel, your temperature will not show the heat, but it's very hot. Now how do you know कि it's hot? जब टेम्परेचर में पता ही नहीं चल रहा है तो हाउ कैन यू नो दैट इट्स हॉट? You will know the heat in the exosphere by the speed of the movement of air particles. ये कितने स्पीड से यहाँ के एयर पार्टिकल्स मूव कर रहे हैं, दैट विल टेल कि एट what temperature or how much heat this body is. So that's the difference between heat and temperature. For temperature, you need two bodies. One body in its own it can be heat, it can be hot, but to check the temperature, you need to make a comparison. कि ये इतना है तो इससे ये कितना ज्यादा है या इससे ये कितना कम है. So when you measure temperature, you make a comparison. When you measure heat basically is the intrinsic property of the body. वो उसका अपना है. It doesn't need to compare it with anyone else. So heat is the intrinsic property. Temperature is a relative concept. This is clear why exosphere will be hot, but you will not feel hot because it has very thin air. Palak is saying the definition of heat. कोई बताओ definition of heat. Definition नहीं. Heat क्या है? Heat is a form of energy. नहीं, heat को क्या बोल सकते हैं? Heat is the kinetic energy which is stored in any body. जितनी उसकी kinetic energy of its particles, that's its heat. The more stored energy of a molecule के terms में देखना थोड़ा सा वो है, हाँ, but if you see it as a body of substance, तो उसकी जो stored energy है basically the kinetic energy that it has, that's it heat. Heat को और भी कहते हैं कि it's ability to do work, it's energy. हीट को मेजर करते हैं जूल में. देवाशीष सेइंग कि बॉडी रेस्ट में होगी तो काइनेटिक एनर्जी कैसे होगा उसमें? Anybody can tell me that when a body is at rest, how it will have kinetic energy? जल्दी जल्दी बताओ, ये सब मुश्किल सवाल नहीं है. Yes, kinetic energy is because of the molecules which are moving. The whole body is not moving, the body move. The atoms, the molecules are always in movement. Your room is not moving, but the air molecules in your room has the kinetic energy. So anyway, weather and climate. Weather climate हमने देख लिया. Weather hour to hour change है. Climate is long period weather condition. Temperature we have read. Now insolation is a very important concept. Insolation is the incoming solar radiation intercepted by the earth. तो solar radiation तो बहुत आ रहा है in huge quantity, but only a part of the solar radiation which is coming is actually coming to the earth. Most of it is reflected by the atmosphere itself. So the part which actually comes to the earth's surface is known as insolation. Now this insolation defines what kind of temperature we will have at what place. The amount of insolation decreases from equator towards pole. We have read this in class 6 NCERT, if you remember, the cardboard experiment. If the cardboard is straight, it will have higher insolation. It will receive more energy. If it is tilted, it will have less energy. So the temperature will decrease from equator towards pole. Now, you can understand why poles have snow. अब दूसरा एक अच्छा यहाँ पे एग्जांपल है, मेंस का क्वेश्चन बनता है अर्बन हीट आइलैंड्स. Now the earth temperature rises too high, it would become too warm for some crops to grow. अगर अर्थ का टेम्परेचर बहुत ज्यादा हो जाता है तो not only many plants, many animals will also die. Our temperature in the cities is much higher than the temperature of the village. Normally, if you have seen, the temperature in the cities will be very high in the same vicinity. So you go to Delhi and you move 20-50 kilometers outside the Delhi and you will feel much colder, not cold, but much cooler atmosphere. ये क्यों हो रहा है? The concrete and metal in the buildings and the asphalts of the roads get heated during the day. And this heat is released during the night. The building's concrete will absorb the heat throughout the day. And in the night, they will start releasing. So in the night time, when temperatures should have declined, it will not decline. And in Delhi, in Bombay, you will feel, not Bombay का थोड़ा different concept है, but in these cities like Delhi, even in the main cities of the Bombay, you will feel much higher temperature than it should be. Also, the high rising buildings of the cities trap warm air and thus raise the temperature of the cities. इसके लिए टर्म क्या यूज करते हैं? अर्बन हीट आइलैंड. So all around the place you will find less temperature and suddenly in the cities you will have very high temperature. तो ये island की तरह लगता है. All the area is surrounded by less temperature वाला region and in urban cities very high temperature. Celsius was invented by Andreas Celsius and the Celsius scale is from 0 to 100. One task you should do, I know most of you have forgotten by now, but try to learn about the transition between Fahrenheit, Celsius and Kelvin. क्या स्केल होता है, कैसे ट्रांसफॉर्म करते हैं, what is the formula, you should know. एयर प्रेशर. देखो यहाँ पे मैंने लिखा है कि दिस इज द 50% ऑफ योर क्लाइमेटोलॉजी. इसको समझ लो तो क्लाइमेटोलॉजी समझ में आ जाएगी. What's happening here? We know what is atmospheric pressure or air pressure. Air pressure is defined as the pressure exerted by the weight of air on the Earth's surface. At every point of time, wherever we are, the air present in the atmosphere is exerting some weight on Earth. And it's also exerting some weight on us. क्या कर रहा है? एयर चारों तरफ से अपने को दबा रहा है. So the pressure which this air puts is known as air pressure because of its weight. Now, it's a very interesting fact here. I hope most of you know about this. Why do astronauts wear suits? On the moon, because of less gravity, the atmospheric pressure is not that high. what happens on Earth that when atmosphere put pressure on us, let's suppose the pressure is 1 atm, 1 atmospheric pressure. Our body also, our body is structured in such a way that we also exert similar amount of weight on the atmosphere, and that's why we are in the situation in which we are. If our body will not exert the similar pressure, the air pressure will crush us. हम कोका कोला की बोतल की तरह क्रश कर दिए जाएंगे एटमॉस्फेरिक प्रेशर में. बट बिकॉज we have we are maintaining the same atmospheric pressure of the equal to the atmospheric pressure, the both forces are cancelled. You can also relate it to the divers. When divers, the ocean, those who dive deep into the oceans, they cannot dive down more than a particular level, because as you are going down, the pressure is increasing. Now the pressure is not just of what air, pressure is also of water. So the pressure will increase and will start to clog your veins. It will start to clog, crush your body. Ulta hoga when you will go to moon. On moon there is no atmospheric pressure, where our body is accustomed to provide external force. So on moon what will happen? Our blood vessels will burst. फट जाएगा सब. balloon की तरफ फट जाएंगे हम. Internal pressure will become more than the atmospheric pressure. Now coming to the important part of it, तो वो पूरा wind movement कैसे होता है? In the last class we have discussed about कि air moves from high pressure to low pressure. You probably remember that. Now how this low pressure and high pressure is created? The simple idea is, listen to this carefully. Let's suppose here the temperature is high. Because of high temperature, the air molecules will get heated. When they will get heated, what will they do? They will start rising. As we have read, if something will get heated, its density will decline, it will get lighter and start rising, right? So high temperature will lead to rising of this air. When it will rise, it will create low pressure here. You have low pressure in this region. Now, correspondingly, you have an area where you have low temperature. Now, this low temperature is relatively low. ऐसा नहीं कि पूरा ठंडा ही है. It's relatively low. So let's suppose here you have 20 degree and here you have 15 degree. So here you have a relatively low temperature. Now, at this place, air is not getting heated. Because of the low temperature, air will get cooler and the cool air will become heavier. So it will stuck down here. A lot of air will come down. The air will get cooler and cooler and cooler, and it will come down here and it will pile here. Now, after a certain limit, you cannot pack in more air here. So it has to flow somewhere and will start flowing from high pressure to low pressure. So what we can now see, that wind will always blow from a low temperature region to a high temperature region, or ulta bole to wind will blow from high pressure area to a low pressure area. Now, some people get confused. you are saying that air is also coming from the top to the bottom, and air is from here, air is going from here to here. So it seems ki here we have a low pressure and here we have a high pressure. And if you see in atmosphere, a change also occurs in this. So air actually moves in a circular manner. अरे एयर इस तरीके से मूव करता है. Here you have low pressure, so from low pressure air is moving towards high pressure. Now ये देख के उल्टा लगता है कि how it can happen. Here we have high pressure and it's moving. यहाँ we have a low pressure and it's moving towards high pressure. This is making no sense. Here we should have relatively higher pressure. तब तो एयर इधर आ रहा होगा. क्या क्वेश्चन है सर? but sir, when body at rest, there is no kinetic energy. When body is at rest, the whole body does not have a kinetic energy. But when you see at a molecular level, it always has the kinetic energy of the molecules. And when you heat something, it gains kinetic energy. और अलग इसे कि काउंटर प्रेशर क्या है? काउंटर प्रेशर, आवर बॉडी इज डिजाइन्ड इन सच अ वे. Life on earth would not have been possible if our body would not have been designed in such way. हमारी बॉडी इस तरीके से डिजाइन की गई है कि जितना एटमॉस्फेरिक प्रेशर होगा उतना प्रेशर हम एक्सर्ट करेंगे उल्टा एटमॉस्फेयर पे. नहीं तो क्या? थिंक अबाउट टू एलिफेंट्स फाइटिंग. The elephant which will put less pressure will be pushed. ये भी प्रेशर, ये भी फोर्स लगा रहा है, ये भी फोर्स लगा रहा है, तो जो कम फोर्स लगाएगा वो उसको धक्का दे देगा. तो वैसे ही एटमॉस्फेयर इज फोर्सिंग अस एंड वी आर फोर्सिंग एट atmosphere, and that equilibrium is maintained. Equal force is exerted by both, and if that force will get disbalanced, either we will get punctured or we will burst. Now यहां क्या हो रहा है? वापस आओ. लो प्रेशर हाई प्रेशर का क्या चक्कर है? सो यहां पे ये ठीक है, एयर इज मूविंग फ्रॉम लो प्रेशर टू हाई प्रेशर. Here you have high pressure and here you have low pressure because air is moving from here to here. Air always moves from low pressure to high pressure. Sorry, air always moves from high pressure to low pressure. But यहाँ पे तुमको लग रहा है कि ये तो उल्टा हो रहा है. हाई प्रेशर से लो प्रेशर से हाई प्रेशर की तरफ क्यों जा रहा है एयर? This is not actually high pressure. This is also low pressure. This is lower than the pressure of this place. Relatively low है. मान लो कि यहां पे प्रेशर है 100, तो यहां पे प्रेशर है 90. So it's moving from a region of high pressure to low pressure, but यहाँ पे प्रेशर है 110. So इसके कंपैरिजन में ये लो है. So it's moving from here to here. And but here when we are saying कि यहाँ पे low pressure है, so here temperature is, suppose here temperature will be about 80. So here you have low temperature, low pressure. तो यहाँ 90 है, तो ये यहाँ से यहाँ जा सकता है. रिलेटिव पोजीशन से और डिटेल से देखेंगे, चिंता मत करो. अभी इतना याद रखो कि एयर, ये वाला कॉन्सेप्ट मुझे भी बोलना ही नहीं चाहिए था, ये तुम लोगों को और कंफ्यूज कर रहा होगा. Just remember this, air is moving from low pressure to high pressure. Where you have high temperature, you will have low pressure. High temperature से क्या होगा? Air will get heated, it will rise up. Because of low temperature, the air molecules will get cooler and will become heavier, so they will come down, and the air will flow from high pressure to low pressure. ठीक है? हाई प्रेशर विन लो टेम्परेचर, इतना याद रखो. हाई प्रेशर होगा, ये तो समझना आसान है ना. हाई प्रेशर होगा तो लो टेम्परेचर होगा, बिकॉज एयर विल बिकम हैवी. व्हेन इट विल कम हैवी, इट विल सिंक डाउन. तो जहां पे सिंक डाउन करेगा तो प्रेशर ज्यादा बनाएगा. हवा आके उसको दबा रहा है ऊपर से, हवा ज्यादा दबाएगा तो प्रेशर ज्यादा होगा. Now, read it once. In areas where temperature is high, the air gets heated and rise. This will lead to creation of low pressure area. In the low pressure areas, you will have cloudy sky and wet weather. Low pressure area में you will have cloudy sky. Why? In low pressure areas, here temperature is high. So the water will get evaporated. Water will get evaporated and it will lead to the creation of clouds. In high pressure area, water is not getting heated, so there will be no formation of cloud. So we see in our, it's a common observation also. In winters, there will be less cloud, there will be less rain. In summers, there will be more clouds, more rain. Similarly, in the areas of low temperature, the air is cold and that's why it's heavy. Heavy air sinks and create a high pressure area. High pressure is associated with clear and sunny sky. And the air will always move from high pressure to low pressure. Now wind. The movement of air from high pressure to low pressure is called as wind. जो भी हम देखते हैं, that's wind. Now this is very important. How we name wind. You might have heard those from North India. तुम लोगों ने अपने पेरेंट्स, ग्रैंड पेरेंट्स को कहते हुए सुना होगा कि पूर्वा चल रहा है, पछुआ चल रहा है. सुना है? So how do we name the winds? मुझे पहले कभी नहीं समझ में आ रहा था कि इन लोगों को कैसे पता चल रहा है कि पूर्वा चल रहा है कि पछुआ चल रहा है. How do we know name the winds? So this is the convention. We name the wind from the direction of its origin. So from whichever direction the wind will be coming, we will call it that. So if the wind is coming from the west, we will call it westerly. If wind is coming from the east, we will call it easterly. ठीक है? Origin के हिसाब से देखते हैं. It's not about कि in which direction it's going. We always track कि from which direction it's coming. Now, this topic we are not touching today. We will discuss this in class 11th or class 10th. So have patience. Let's discuss about this moisture. Palak is saying cloud concept. Cloud का concept क्या है? When there will be, I think you are asking about this. When there will be high temperature, water will get evaporated. When water will get evaporated, it will rise up, it will create cloud. तो गर्मी में बारिश होगी, बस उसी पे आ रहे हैं अभी, उसको डिटेल से कर रहे हैं। देखो वही टॉपिक है, मॉइस्चर। सो मॉइस्चर इन द एयर at any time is known as humidity. I'm giving you a task. Normally I would have explained, but थोड़ा मेहनत करो. Read about absolute humidity and relative humidity. In the next class, I will ask you what is absolute humidity and what is relative humidity. So humidity is the moisture that is present in air. So in air, there will be some H2O, water molecules present, the water vapor present, that leads to humidity. So more water vapor, more humidity. In some time, in summers, you might have felt कि बहुत एक गर्मी होती है ना, चिप चिप वाली गर्मी होती है, तो तुम्हारा पसीना है वो सूख ही नहीं रहा है, सूख ही नहीं रहा है. एंड इफ यू आर फ्रॉम द रीजन्स ऑफ बुंदेलखंड और मध्य प्रदेश, राजस्थान, you on in those regions, the heat will be like it's burning, it's scorching your skin. There is no sweat, लग रहा है कि जल रहा है, because the air is very dry there. It will quickly evaporate all the air on your surface, but it will burn you. But you come to West Bengal, the air is very humid. You go to south places near oceans where there is high humidity, and the heat will be not scorching, but वो sweaty वाला, चिपचिपा वाला गर्मी होता है. तो हाँ, right, during during rainy days, humidity will increase, and that will, because of that, it makes us uncomfortable. Now about the rain, I think all of you have read this in your schools. Water vapor will rise and it will cool. When it will start cooling, it will condense there, and when it will be condensed, it will start falling, and when it will fall, it will lead to rain. This process is called as the process of precipitation. You might have seen jet planes. वो अपने पीछे एक ट्रेल छोड़ के जाते हैं, कई बार देखा है तुम लोगों ने. आई होप ऑल ऑफ यू मस्ट हैव सीन. पीछे उजला उनका पूंछ बहुत बड़ा सा छूटा रहता है. So those white trails are nothing but moistures from the engines which have condensed in the air. Now, precipitation is not always rainfall. Precipitation can be in the form of rain, can be in the form of snowflakes, can be in the form of ice. गोला भी बरसता है. So it can be in the form of snow, or it can be in the form of slit. जैसे if you will go to Kashmir, or if you go to hill stations, there you will not find ice. The ice there will be very fine. They will fall in the form of a slit. तो दोनों तीन अलग अलग टाइप है. We'll read about this later, but I just wanted to make a difference. Ki all precipitations are not rain. If the precipitation is coming in the liquid form, then only it is called as rain. Now, rain के होने के तीन ही reason है: conventional, orographic, and cyclonic. So let's see all of this. First, the conventional rainfall that we read. Convention के हिसाब से जो होता है, water will get heated, go up, will form the cloud and then precipitate. So this is conventional style. Then there is this orographic style. Generally क्या हो रहा है? We have read that higher we go, cooler we feel, right? Now, after a certain height, there is a term. I'm not going into the technicalities of it, but बाद में आके देखेंगे. There is a term called as adiabatic lapse rate. Yeah, you can just remember lapse rate for now. Lapse rate says that as we go up, we lapse temperature, the temperature declines, and there is a fixed number. So like if I'm not wrong, it's about 6.4 degree Celsius for each kilometer. If you go 1 kilometer up, the temperature will fall by 6 degrees. Now, let's suppose an air is here at the surface. So an air is here at the surface, and it started to rise. At the surface, its temperature is 20 degrees Celsius. Let's suppose this has water molecules in it and it starts to rise. So as per this rate, let's suppose after every 6 kilometer, it's losing its temperature. So after 4 kilometers, it will lose how many degrees? About 24 degrees it will lose. So we can say that at 4 kilometer height, this air's temperature is now -4 degree Celsius. ये जम गया अब, पानी ऊपर गया, ऊपर जम गया अब. So if this air will rise up to a certain height, it will freeze. ठीक है, ये समझ में आ रहा है? If a air packet will go up, its temperature will decline. So if it will go up by 3-4 kilometers, it will become negative also. So this is what happens here. First, air is heated. Because it has become heated, it will start rising and will lose its temperature, and then it will fall back. और हमको इसमें बहुत डिटेल से बात करेंगे. Now think about this mountain. Here it was conventionally, it was going on its own. But here, a wind is coming and it will collide with the mountain. Now, because of the mountain, it will start rising up with the mountain slope. So let's suppose if the temperature of the air was 10 degree and if it will rise by 2 kilometers, it will become -2 degree. It will freeze. So now this cloud will have frozen water. And when it will rise here, it will become too heavy and it will start precipitating after a certain height. So this is known as orographic rainfall. Oro means mountain. So the rainfalls which are happening because of mountain. पढ़ेंगे और details से इसमें. The third factor is cyclonic rainfall. Now we are not going into the details of it. We will read about this in higher classes. But just remember that the third type is cyclonic rainfall. We have seen that because of cyclones, rainfall happens. So let's end this chapter here. Let's move to chapter number 5. Terrarium is like aquarium, but it has earth. Aqua water का बनाया तो aquarium, मिट्टी डाल के बनाया तो terrarium, terra. We have already read about the water cycle. The water is going up, condensation, and then precipitating, and then again evaporation, condensation, and precipitation. The cycle is going on. The precipitation can happen in the form of rain, snow, or sleet. Now this question has been asked by UPSC twice. Ocean में water है 97.3%. Ice cap में, so this is all the saline water, and we have about 2.7% fresh water. So of this 2.7%, the largest amount is in glaciers, ice caps. Of this 2.7%, the rest is in groundwater. Then some of it is in fresh water lakes and salt lakes, inland sea salt lakes. It's very surprising, and UPSC plays with this too. Atmosphere and river. See, in the river, we have less water than we have in atmosphere. Very surprising. Nowadays, scientists are making devices which can capture the water from the atmosphere and give you fresh drinking water without anything. It can direct capture the moisture that is in the air. So we have more water in atmosphere than in rivers. UPSC अरेंज करने के लिए दे देता है कि अरेंज द फॉलोइंग सोर्सेस, ग्राउंड वाटर, आइस कैप, एटमोस्फेयर एंड रिवर, एंड पीपल मेक मिस्टेक बिकॉज हम लोगों को तो रिवर में बहुत पानी दिखता है. Now, salinity. See, I hope all of you have. How many of you have done experiments in your class 10th 11th? सही में किसके यहाँ साइंस का एक्सपेरिमेंट होता था? That's a most of the school doesn't happen. तुम्हारे स्कूल में होता था क्या? मेरे स्कूल में होता था. So, and one of the very famous experiment was this salt water experiment. We used to dip a rock tied in a thread into the water body, and then we used to measure the weight. The more salt we used to add into the water, the weight used to become lesser and lesser and lesser. So पहले तो ये समझना है कि weight of anything that we measure, it depends upon the amount of force that thing is exerting upon the surface. There's a difference between weight and mass. It's the same difference that we have between temperature and heat. चलो ये भी करके आना, पढ़ के आओ थोड़ा सा कि what is the difference between weight and mass. Those who are not from science background, those who are, it's good. So salinity is the amount of salt present in the water of 100 grams. So if we take 1 kg water and we add 35 parts per thousand, means इसको शॉर्ट में बोलते हैं PPT. In 1000 gram, I am adding 35 grams of water. In 1000 grams, I'm adding 35 gram of water. Then the salinity will be called as 35 PPT. Now, this is the average salinity of the ocean. If you'll go and drink the ocean water, कभी ट्राई किए हो? बहुत खतरनाक होता है. Don't try. So the salinity is very high. In 1 kg, think if in 1 kg water, if you will mix 35 gram of salt, it will be very saline. So this is the average salinity. At some places, like in Dead Sea, in 1 liter of water, you have 340 grams of salt. And that's why in this, nobody is drowning. The bouncy force is so high that if you go to the Dead Sea, you will not drown. नाम उल्टा है. In the Dead Sea, nobody actually dies. Now, ocean circulation. Ocean water is constantly moving. It is never still. There are three kind of movements in the ocean: waves, tides, and currents. Now, waves are pretty simple. Waves that we saw, that we see on the surface, is the wave. But there is very interesting thing happening in the waves as well. Waves, as we see, if you will, if you have a microscope and if you look at the individual molecules of the water on the surface, they are not moving in a straight line. ऐसा नहीं कि ये water molecule है वो भी ऐसा ऐसा होके move कर रहा होगा. No, water molecules move in a circular fashion. So what will happen? Let's suppose here you have a water molecule. So first it will go up, then it will come down, and it will rotate. The water molecules below it will also will rotating, and they will move in a circular manner. इस तरीके से रोटेट हो के वाटर चलता है इंडिविजुअल मॉलिक्यूल्स को अगर देखें तो. Now why this wave like pattern? This is happening because of air. So first thing क्या हो रहा है, ये जो फॉरवर्ड मूवमेंट है इट्स बिकॉज ऑफ एयर. एयर इज pulling it forward because of the frictional force. How can you understand this for the non-science background students? Let's think about this. This is a piece of paper. Now, let's suppose this first paper, like there are three seats here. You can take more seats if you have. इसी से काम चलाते हैं. So let's suppose this first seat is your air. If you will pull this first seat, it will put some friction upon the lower seats as well. You try to do it more number of seats. If you will pull the seat, it will also be pulled, although not in the same magnitude, but it will also be pulled. है ना. ऐसे डेक पे पेपर रखो और ऊपर वाले सरफेस को ऐसे पुश करने की कोशिश करो आगे. सारा लेवल नीचे के भी लेयर्स पुश होंगे, राइट? गेटिंग माय पॉइंट? नॉन साइंस वालों को साइंस समझाना थोड़ा मुश्किल होता है. तो यू गेटिंग व्हाट आई एम टेलिंग? हाउ द फ्रिक्शन फोर्स वर्क्स. one layer the air will push or will pull the water level with it. तो मान लो कि ये ऊपर वाला एयर अगर मूव कर रहा है 1 किलोमीटर पर आवर की स्पीड से, या फिर मान लो 5 किलोमीटर पर आवर की स्पीड से, the layer just below it will be moving by 4 kilometer per hour. The layer below it will be pulled by 3 kilometer per hour. The layer below it will be pulled by 2 kilometer per hour. The speed will be going slightly slowing down, and these waves will not be forming at the bottom of the ocean. These waves will be limited to the top few layers. एक मिनट रुको. So see, now I have this a lot of sheets with me. Think about these sheets as water. One layer of water. One sheet is one layer of water. Another sheet is one other layer of water, right? Can you do this? Can you imagine this for me? This is the layer of water. And as we are going down, this is a huge, like a lot of layers of water, layers of water, layers of water. Now, if I'm pushing it, if I'm pushing the top layer, the bottom layers are also being pushed. I'm pushing the first layer only, but the impact is on also on some layers, but it's not impacting the layers which are deep down. The impact of this force will be limited to the top few layers only. तो वेव्स जो बनेंगे वो ऊपर के ही कुछ लेयर से बनेंगे तो मे बी if we see by the height so it will be forming at 100 meters. 100 meters भी बहुत हो गया तो मैक्सिमम 100 200 meters के आसपास कुछ ऐसा ये waves बन रहा होगा but if you go down you will find that ocean is completely silent. उसमें ऐसा waves नहीं बन रहा है. Movement is there but there is no waves. Now what happens here? Why the waves? देखो ये क्या होता है कि this part is being first it is with the air molecule it is pulled up but at the next moment it is pulled down by the gravitational force so it comes down, it goes down, then again it is pushed by the bounce force of the water. तुम लोगों ने देखा अगर वाटर पे हम ऐसे बॉल या वाटर पे ऐसे प्रेशर डालते तो वाटर भी हम पे ऊपर एग्जर्ट करता है external force. If you know the physics, if you will apply some force on the water it will apply equal force on you. तो क्या होता है ये ऐसा प्रेस किया फॉल किया वाटर मॉलिक्यूल को फिर ये वापस थ्रो किया वापस एंड इन दिस रोटेशनल वे इट विल कीप ऑन रोटेटिंग ऑल्दो नॉट दैट यू डोंट नीड टू रीड इट इन दैट डिटेल. समझ लो थोड़ा बहुत आइडिया लग गया हो कि ये वेव के फॉर्म में ही क्यों मूव करता है ये आराम से सीधा सीधा क्यों नहीं मूव करता है. So waves are formed when wind scrape across the ocean surface. The stronger the wind blows, bigger will be the waves. जितनी तेज हवा चलेगी उतना ज्यादा बड़ा waves बनेगा. Rising and falling of the ocean water is called wave. कभी कभी ये सुनामी का फॉर्म ले लेते हैं and waves become very high. इसको आके देखेंगे कभी. Tides. Now this is what I was planning to teach today. I don't know how many of you are left with the enough energy to read this. Very much energy consuming लेकिन बहुत मजेदार है. Tides. Now our normal idea is it's saying that the rhythmic rise and fall of ocean water twice in a day is called tide. Like whatever we are reading here all is wrong, or if not wrong it's too much generalization of what it is. क्या करें कि rhythmic rise and fall of ocean water in a day twice in a day is called tide. High tide when water covers much of the shore by rising to its highest level, and low tide when water falls to its lower level and recede from the source. एक normal situation देखते हैं what's happening. Let's suppose this is ocean and this is your beach. This is your ocean. This is the water body, that water, and this is the average level. Average ये है. During high tides, what happened? And you are standing here. So during high tides, what happened? That this water will rise, and if you will not move from your situation, it will rise up and cover everything. It will drown. So those who are from beach areas, they know that water, it looks like that water is coming towards you. If you're standing here, water will start coming and start coming. You go and sit around a beach for hours and you will see कि पानी धीरे धीरे आगे बढ़ रहा है. So this is high tide, and it will reach up to its maximum point. And then after that, it will start receding. And then it will go back to its normal average position. More, पहले ये इसका एवरेज था, इससे भी पीछे चला जाएगा. And this will be called as low tide. So when the water level will rise more than its average level, or to its highest level, it is high tide. And when it will go back to its lowest level, it is low tide. अब क्या कह रहा है? The strong gravitational pull exerted by the sun and the moon on the earth's surface causes the tide. कह रहा है कि gravitational pull tide क्यों होगा? सन एंड मून के पुल के चलते. ठीक है, लेट्स सपोज कि इट्स करेक्ट. द नेक्स्ट पॉइंट इज द वाटर ऑफ द अर्थ क्लोजर टू द मून गेट्स पुल्ड under the influence of the moon's gravitational force causing high tide. High tide का रीजन क्या बता रहा है? That the water which will be closer to the earth. So let's suppose गोवा का बीच है, and if sun will or if the moon will be directly above the Goa, it will pull the water and there will be high tide there. But as you can see in any of the maps, that high tide does not come in one side. अगर ये बात सही होती तो क्या होता? इस मैप के हिसाब से there would have been high tide here and low tide here, because here you have the highest gravitational force and here you have the lowest gravitational force. So it should have pulled. यहाँ का भी वाटर किधर पुल होना चाहिए था? मून की तरफ पुल्ड होना चाहिए था. So how is it that we have high tides here as well as high tide here? समझ में आ रहा है मैं क्या बोल रहा हूँ? Can you see the problem here? Had it ever occurred to you कि क्यों ऐसा हो रहा है? If the moon's gravitational force is responsible for tide, तो क्या होना चाहिए था? यहाँ हाई टाइड और यहाँ लो टाइड होना चाहिए था, है कि नहीं? यहाँ हाई टाइड हो रहा है तो यहाँ लो टाइड होता, है ना? तो व्हाट, ये गड़बड़ क्या हो रहा है? अब बोलो, आज समझना है कि कल समझना है? Want to who have the detective attitude, who want to go to the root of the problem? ठीक है, आज देखते हैं. See what's happening here. you need to remember a few things, or you need to understand a few things. First, we have discussed about how gravitation works, right? Gravitation is mass of the two body and their distance, right? M by r ka square with some constant. So this is how gravitational force works. Now, see, this is our Earth, and this is, let's suppose, our moon. And at very far distance, we have our sun. Now, on Earth, if we see the gravitational force, if we compare the gravitational force of the moon and the gravitational force of the sun, moon actually impacts or has higher gravitational force or gravitational pull than the sun. Although sun is very high, or sun is very big, normally ये होना चाहिए कि the bigger the object, more gravitational force it should have. Lekin because moon is located at a very near distance, because the radius is low, the distance is low, moon का gravitational force is much more effective. तो हमें पहली बात क्या रखना है कि for the creation of tides, the gravitational force of moon is more active or more powerful or more strong than the gravitational pull of sun. ये बात समझ में आई सबको? क्यों gravitational pull of moon ज्यादा impact करेगा, sun नहीं करेगा? Because of the distance. Now, this is Earth. अच्छे से ड्रॉ करते हैं. This is Earth. This is your moon. Let's suppose here you have a water body. यहाँ पे तुम्हारे पास प्रशांत महासागर है, यहाँ पे अटलांटिक ओशन है. Now, this water body is pulled by the moon. So naturally, let's suppose here we have a gravitational force acting as, let's suppose this has 3 points. This is the center of the Earth. This is point A. This is point B, and this is center of the Earth, C. B is exactly opposite to A. तो ये अगर 0 डिग्री है तो ये 180 डिग्री होगा, ऐसा मानते हैं. So moon is pulling point A because of the gravitational force. So at this point, the water will rise. Now, technically, the gravitational force should also be acting at this place, and instead of rising, it should have squeezed. हाँ, तो पहले देखते हैं कि तीनों पे क्या क्या ग्रेविटेशनल फोर्स लग रहा है. So gravitational force at A will be greater than gravitational force at C, and it will be greater than the gravitational force at B. All are agree with this. यहाँ पे ज्यादा ग्रेविटेशनल फोर्स लग रहा होगा, यहाँ पे उससे कम लग रहा होगा, और यहाँ पे बहुत कम ग्रेविटेशनल फोर्स लग रहा होगा. ये ठीक है सब के लिए. Because of the distance, this is much closer to A, This is a little bit farther and this is more farther. The farther we go, lesser will be the gravitational force, right? सबसे ज्यादा ग्रेविटेशनल फोर्स इस पे लगेगा, जी ए पे, बिकॉज इट इज मच क्लोजर. तो जितना क्लोज उतना ज्यादा फोर्स. हाँ नाम बोलो, जल्दी आगे बढ़ेंगे. ये ठीक है ना? हाँ. ओ, ये लास्ट वाला जी बी लिखना है, जी सी मैंने लिख दिया, सॉरी, जी बी. नाउ जिस पे जितना फोर्स लगेगा उतना डिस्प्लेसमेंट होगा और उसकी वेलोसिटी उतनी ज्यादा होगी. If you will pull something with greater force, it will it will be displaced more. If you will pull something with lesser force, it will be displaced less, right? So what I can say is that displacement at A will be higher than displacement at C and then displacement of B. मतलब ये मान लो कि अगर 1 किलोमीटर, 1 किलोमीटर नहीं, I'm just taking a number कि if A is pulled towards B by 1 kilometer, B will be pulled by probably 0.8 kilometers and C will be pulled by 0.5 kilometers, right? अभी समझाने के लिए बता रहा हूँ, एग्जाम में कुछ ऐसा लिखने का जरूरत नहीं. Sir, will the displacement will be less. Let's suppose you are standing at C. You are a person who is standing at C. तुम्हें क्या दिख रहा होगा? तुम तो 0.8 किलोमीटर आगे बढ़े हो मून की तरफ. तुम 0.8 किलोमीटर आगे बढ़ गए. But point A has moved 1 kilometer. So after that point, you will feel that point A has moved 0.2 kilometer ahead than you. A तुमसे 0.2 किलोमीटर आगे दिखेगा after some time. So it will feel like it has moved that much. Now when you will look at B, what you will see? You have moved 0.8 kilometer. That B has just moved 0.5 kilometers. So it will look like that B has left behind by 0.3 kilometers. तुम्हारे पीछे देखोगे, अच्छा बी तुम्हारे से 3 किलोमीटर 0.3 किलोमीटर पीछे खड़ा है. So actually what's happening that इसको हम लोग सेंट्रीफ्यूगल फोर्स कह सकते हैं. Centrifugal force, which is a imaginary force. It's not a real force. It's actually coming towards you, but the displacement, the relative displacement is not as much as the position of Earth is. So वो क्या लगे, वो पीछे छूट गया है, तो वो बल्ज टाइप का दिखेगा. सो यहाँ पे एक्चुअल फोर्स काम कर रहा है, यहाँ पे सेंट्रीफ्यूगल फोर्स काम कर रहा है. दिस इज वन एक्सप्लेनेशन ऑफ द बल्जेस ऑन द टू साइड. बट ये भी अच्छा एक्सप्लेनेशन नहीं है. नहीं समझ में आया तो कोई बात नहीं, जिसको आ गया, आई होप जिसको फोर्स समझ में आता होगा उसको आ गया होगा. नहीं समझ में आया तो हम लोग असली एक्सप्लेनेशन देखते हैं. व्हाट इज द रियल कॉज ऑफ ऑल दिस? एक्चुअली tides do not happen because of the pull. Tides happen because of the push or the squeeze. कैसे हो रहा है देखते हैं. This is now why I'm telling this. If tide happens because of pull, why we do not feel a storm, or why do not feel a tide in our cup of tea? हमारे कप कप में भी जो पानी रखा है उसको भी चांद खींच लेना चाहिए था ऊपर, उसमें भी ऐसा ऐसा वेव बनना चाहिए था, हाई टाइड्स एंड लो टाइड्स, बट नहीं होता है. See, those who know a little bit of science, let's try to do this. You have water bodies here. Now, what kind of force moon will be applying on each of the particles of the ocean? एक एक पार्टिकल पे कैसा फोर्स लग रहा होगा, इसको इमेजिन करते हैं. लेट्स सपोज देयर आर दीज particles of water throughout the earth, and let's try to imagine how these particles are being pulled or pushed by the moon. This particle has one force directly in this way. Force direct इधर लग रहा है, इसको इधर pull कर रहा है, simple gravitation. Now what kind of force is acting here? On this point, the force is not straight, it has an angle. If you know a little bit of science, you can see that this atom is pushed, it has two components. One, it's being pulled down, and another, it is pulled forward. दोनों तरफ मूव हो रहा है, और तब जाके इसका एक इफेक्टिव डायरेक्शन ये वाला बनता है. वैसे ही if you look at this also has an effective component forward and another component downward, because the actual movement is like this. This point also, it has a movement like this and a movement like this. Now all the points which are being pulled by the moon have these two components, one component towards the north or towards the south and one towards north. Similarly, यहाँ पे जो point है इस पे, one force going up, one force going towards this, because it is being pulled like this. तो हर एयर पार्टिकल पे, सॉरी हर वाटर मॉलिक्यूल पे इस तरीके का फोर्स लग रहा होगा. Now effectively what you will see that the water from this top region will actually skews the water. ऊपर से पोल्स के डायरेक्शन से पूरा जो वाटर है, द इफेक्टिव डायरेक्शन इज टुवर्ड्स दिस. तो पूरा वाटर का एक बल्ज यहां बनाएगा, बिकॉज ऑल दिस वाटर इज पुलिंग द वाटर एट द इन द सेंटर, एंड इधर का जो वाटर है बल्ज पूरा इधर बनाएगा. ये समझ में आ रहा है? ये बहुत आसान है समझना. सिंपल फोर्स लग रहा है दो डायरेक्शन में. ऊपर वाला वाटर इसको नीचे दबा रहा है तो यहां बल्ज बन जाएगा, और यहां वाला इधर दबा रहा है तो यहां बल्ज बन जाएगा. So it's very simple. Now you can understand why you will have two high tides. So when it is high tide here at, let's suppose, 0 degree, another high tide will come at 180 degree. If the high tide is at 90 degree east, another high tide will be at 90 degree west. Completely opposite direction पे high tide बनता रहेगा. No. And this you will not find in any book. Next thing is that we read in the first line that it happens twice in a day. Now, by this argument, ऐसा होना चाहिए कि no, the earth is rotating, right? Earth is, let's suppose earth is rotating in this direction. So let's suppose it's 12 p.m. and or 12 a.m. Let's suppose it's night, 12 a.m. and moon is directly above 0 degree. So it will be high tide here. It will start rotating, and after 12 hours this 0 degree will come at 180 degree. So after 12 hours again, so 12 hours कितना हो जाएगा? At 12 p.m. again there will be a high tide, and then again it will come back here at 12 a.m. So again here will be a high tide. तो एक जगह पे in 24 hours you will find 2 high tides. Is it clear? देवेश इज सेइंग कि 180 डिग्री वाले पे एग्जैक्टली किधर फोर्स लगा. देखो इसलिए मैंने कहा कि फोर्स नहीं, ये स्क्यूज हो रहा है. पूरा जो ऊपर का वाटर है इट्स स्क्यूजिंग इट. तो तुम रबर का बल लो और दोनों तरफ से उसको अगर प्रेस करो तो बल्ज, चारों तरफ बल्ज क्रिएट होगा. If you look for the force, if you will try to find the explanation in the gravitational force, it will not give you the explanation. It's happening because of the skews. तो होना ये चाहिए कि in every 24 hours there should be 2 tides, 2 high tides and 2 low tides. क्योंकि जब ये इस पॉइंट पे होगा अपोजिट पे, तो there will be low tides. But there is a catch here. Now if you can follow this with me, that will show you how much concentration power you have. Write it down. One revolution of moon happens in how many days? One complete revolution around Earth, 27.5 days, right? ठीक है? One moon revolution around Earth. So one revolution is 360 degrees, and moon is rotating these 360 degrees in. If you convert it to hour, it will be 660 hours. So moon is rotating 360 degree around the moon in 660 hours. So if you will find in 1 hour, moon will be rotating how much? 360 by 660. In 1 hour, it will be rotating this much. Now, if you will multiply it with 24, in 24 hours or in 1 day, if you'll do the maths, it will come to 13.09 degrees. So in 24 hours, the moon travels 13 degree. If this is Earth and this is your moon rotating around it. So after every day, after 1 day, so if let's suppose it's starting from 1st January, so on the 2nd January, it will have rotated 13 degree. In the next day also, it will have rotated 13 degree. So in this way, in 27.5 days, it will complete its journey, one revolution. Now here it becomes interesting. 13.2 degree roughly translate to 42 minutes. Just keep this in mind. 13.9 degree roughly translate to 52 minutes of Earth. कैसे हुआ? हमारे यहाँ क्या है? If we see the revolution of Earth, Earth rotates 360 degree in 24 hours. So this gives us in 1 minute we rotate कितना? 4 degrees. Sorry, उल्टा बोल रहा हूँ. हमने देखा था लास्ट टाइम कैलकुलेशन में, we rotate 1 degree in 4 minutes, right? So if you multiply 13 degree into 4, it will give you about 52 minutes. This is clear? 13 डिग्री का रोटेशन कितना होता है? 52 मिनट्स. क्यों हम 52 मिनट्स निकाल रहे हैं मैं समझाता हूं इसको. Let's suppose this is Earth and this is your moon. It is revolving around the Earth. In one day, it covers 13 degree, 13.9 degree. अब ऐसा सोचो, you are on the Earth, you are looking at moon. Let's suppose here you are standing on the Earth's surface, and this is your Earth. This is equator. So you're standing at the Earth looking at moon. What you will see, let's suppose at 6 p.m. moon is visible to you. For the first time, moon come into the sky and you are able to see the moon. Okay? Now moon will be visible to you for next 24 hours. ठीक है? Moon तुम्हें next 12 hours तक दिखता रहेगा until it is 6 a.m. Normally it should behave like this, right? 12 घंटे तुमको मून दिखना चाहिए, तुम एकदम इक्वेटर से खड़े होकर मून को देख रहे हो. But what will happen next day? Let's suppose this is 1st January. On the next day, at 6 p.m. when you will look here, moon will not be there. Because moon has moved forward. By how much? By 13 degree. So instead of being here, moon will be 13 degree forward here, somewhere. If you want to see the rising of the moon, you have to come 52 minutes early. So moon would have been here at 5:08 p.m. 52 मिनट्स पहले आया होगा कि मून मूव कर गया. कैसे इमेजिन करो, दिस इज योर अर्थ and this is your moon. Now by the time you complete one revolution, by the time you will come here again, moon will not be here again. Moon will move forward. By the next time you will come again here, moon will not be here. Moon will not be here again. Moon will again move forward here. तुम तीसरे दिन एक बार चक्कर लगा के आओगे तो मून अब तुम्हें यहां भी नहीं दिखेगा. Moon will again move forward. What you can actually do in today, you go and try to find the moon in the sky. Or any day, whenever moon comes, it's very difficult to track the moon. So any day when you see the moon, you check the time. Let's suppose any day you see the moon at 9 p.m. and you track the position. Let's suppose the moon is visible to you at 30 degrees. And you go and watch the moon next day. And you will find that exactly at 9 p.m. moon is higher up in the sky by 13 degree. The next day it is again higher up. और ये पूरा चक्कर ऐसा चलेगा कि मून will be visible to you in the daytime as well. Moon will be above your head in the daytime. इसको ऐसे समझ सकते हैं. कितने लोग बचे क्लास में? 32. ठीक है. एक और डायग्राम मैं ड्रॉ करता हूँ and probably this will give you a better picture of what I'm trying to say. We are at here. We are at on the Earth, and from here you are seeing the sunrise. Let's suppose sun rises at 6 a.m. अब 6 a.m. में sunrise देख रहे हो. And sun will rise at 6 a.m. and goes back and it will sunset will be at 6 p.m. Now every day, if you are at equator, this will be the situation will be same. सूरज हर दिन 6 बजे आएगा, 6 बजे जाएगा. If you are not at the higher latitude, higher altitude, जो हमने देखा है पहले ही कैसे altitude का change आएगा. Otherwise, it will every day. You are standing at Greenwich Mean Time on the equator. You will see the same. Sun is coming at the 6 a.m. going down at the 6 p.m. Same time every day. What will happen to? Sorry, sun का बात करूं. What will happen to moon? Let's suppose on a particular day you are able to see moon. Moon and sun are at the same position. The rise of the time of the moon and the sun is same. Moon भी तुम्हें 6 बजे सुबह दिखता है. Now it will be very controversial for many of you कि 6 बजे सुबह moon कैसे दिखेगा. But believe me, दिखता है. अब अगले दिन क्या होगा? This is 1st January. On the 2nd January, when you will come back at 6 a.m., moon at 6 a.m. will not be in this line. Moon has moved 52 degree up or 13 degree up. So, and it will keep moving, keep moving, keep moving. 13 को पूरा एक चक्कर कंप्लीट करने में कितना टाइम लगेगा? On the next day when you will come, the sunrise will be when it will be 6 a.m. Moon will not be there. Moon has moved from its position. This moon will rise probably early in the morning at 8 a.m. 8 में वो इस position में होगा. If you come early, you can see the moon. But now at this point, this is how much? 6:52 a.m. Now at 6:52 a.m. moon is there, but sun is very bright now. So you will not be able to see the moon on the next day. Similarly, on the 3rd January, moon is here and the sun will come here at 6 में और जोड़ दो 2 घंटे, तो it will become here at about 8 a.m. अब मून बहुत ब्राइट है, अब चांद तुमको नहीं दिखेगा. ऐसे ही आगे करते करते on the 3rd January, 4th, 5th, 6th, 7th January, 13 into multiply it by 15. So almost for 15 days, it will keep moving. And on the 15 days, you will see 15th day, you will see कितना multiply करो. 13 into 15 is 150 plus 45. So about 195 degrees. So on about 15 days on about और थोड़ा कम कर लेते हैं 180 डिग्री के लिए, let's suppose on 14th day the moon will be visible to you at 6 p.m. and it will continue with you throughout the night. You can see the moon throughout the night, but in this time you cannot see the moon because sun is there. तो फिर ये 14 दिन के बाद तुमको पूरा मून दिखेगा, रात में तुम्हारे साथ होगा, बाकी दिन वो दिन में होगा. तो फॉर अबाउट 15 days मून इज देयर इन द स्काई, बट इट इज विथ अस ड्यूरिंग व्हेन द सन इज अप. तो इस टाइम में तुमको सन कब दिखेगा? इट विल बी विजिबल टू यू फॉर अ वेरी ब्रीफ पीरियड when there is no sun in the sky. So you can see the moon आफ्टर सनसेट. तो अगर मून देर से आएगा तो देर से जाएगा भी, तो तुम थोड़ी देर के लिए देख पाओगे सनसेट के टाइम में. और आफ्टर 15 days यू कैन सी इट फॉर अ लॉन्गर टाइम. थोड़ा ये बहुत कॉम्प्लिकेटेड हो रहा है, जिसको समझ में आ गया ठीक है, नहीं आया तो आई विल ट्राई बेटर नेक्स्ट टाइम. Now, the point to tell you all this was that moon is not coming at the same place after exactly 24 hours. Moon is coming to every place after 24 plus 52 minutes. तो इसके चलते tides का जो duration होता है, that's also keep changing. So it's not that कि अगर सिर्फ रात में हाई टाइड आ रहा है तो रात में हाई टाइड आएगा. यही एक कॉन्सेप्ट, मिसकॉन्सेप्शन दूर करना था मुझे, कि हाई टाइड्स विल नॉट ऑलवेज कम इन नाइट्स. आई थिंक दिस वन थिंग इज क्लियर टू यू, कि हाई टाइड्स कैन कम इन डे टाइम ऑल्सो व्हेन मून इज above you. High tides can come in day also because moon is above you, and that time of high tide will keep changing. So if high tide today is coming at 6 p.m, the next day high tide will come at 6 p.m 6:52 पे आएगा, 6:52 p.m. तो ये चेंज आता है. और रहने दो इसको, बाकी आके कल करते हैं. थोड़ा सा पोर्शन बचा है, और हाँ ठीक है, कल करते हैं. ये बेकार पंगा ले लिया मैंने. बताओ. हाँ, कुछ पूछ रहे थे तुम लोग. Yeah, it's a little bit tricky. I will tell you better next time. I will. एक चीज और दिखाता हूँ तुम लोगों को. एक चीज I have decided to show you something, but I forgot. Oh, this is very interesting.
In 1959, the Soviet spacecraft Luna 3 beamed back images of something Earthlings had never before seen: the far side of the moon. We always see the same old side of the moon because the moon rotates exactly once on its axis each time it orbits Earth. If it weren't spinning at all, we'd get at least one 360-degree view of its surface with each lap. If it were spinning twice as fast, we'd also see the moon's entire surface more than once per orbit. But instead, our moon's motions, like the spin and orbit of most other moons in our solar system, are remarkably in perfect sync. This wasn't always the case. Our best guess is that our own moon formed due to a massive asteroid impact, and its initial spin and dizzying 10-hour orbit were almost certainly not in sync with each other, though we don't know which was faster. At such close range, Earth's gravity deformed the moon into a slight oval, with one of its bulges facing Earth. Those bulges quickly swung out of alignment thanks to the moon's asynchronous spin and orbit, but Earth's gravity continually squeezed them back again. What's more, this gravitational tugging would have influenced the moon's rotation rate. If it was spinning more than once per orbit, Earth would pull at a slight angle against the moon's direction of rotation, slowing its spin. If the moon was spinning less than once per orbit, Earth would have pulled the other way, speeding its rotation. Whatever the case, it took just 1,000 years for the Earth's pull to adjust the moon's spin enough that one rotation of the moon corresponded to one trip around the Earth, leaving one side forever locked facing away. We do end up seeing some of that far side because the moon's elliptical orbit gives us peaks beyond its average eastern and western horizons, and its tilted axis causes moon seasons, revealing more of the lunar north or south poles. But those glimpses only add up to an extra 9%, leaving 41% of the moon hidden from Earth. Satellites, starting with Luna 3, have allowed us to map the rest, but it's safe to say that our relationship with the moon is still pretty one-sided. I'd like to say a big thanks to Squarespace for supporting.
आया समझ में? जो किसी को कुछ आया समझ में? The same thing that we have discussed in the last class, that moon always faces one side. The explanation and the map was drawing was better, so I thought to show you this. This is known as tidal locking. So one face is always locked towards the Earth's surface. They told it that's a one-way love story. I think of it like the moon has fallen so much love with Earth that it's not looking away, it's constantly looking at Earth. And this happens with all the planets. It's not just with Earth. In all the planets and their satellites are tidally locked because of the gravitation. चलो ठीक है, कल मिलते हैं. We'll continue our discussion. Anything else? Any questions? अरे पोएम कल सुनाऊंगा. क्या सुनोगे? तुम लोग सुनाओ कुछ, किसी को कुछ सुनाना है तो.